In this video, we will now conclude our operations with decimals by looking at division, and at the end, we'll put it all together and examine how we do order of operations. We've talked about that before, but again, now we'll look at it with decimals. And so if you recall from when we divided with whole numbers, we had two concepts. We had what was called the measurement concept, which also was known as the subtractive concept, and then the sharing or partitive concept. Both of those are useful when we start to work with division of decimals as well. The measurement concept is about repeatedly subtracting or measuring off one amount from another. And so if we start this conversation looking at this division problem, 0.90 divided by 0.15. What we're going to do is we're going to imagine taking this amount that we're dividing by, the divisor, and we're measuring it off of or subtracting it from the 0.90 and seeing how many times we can do that. But of course, I'm going to show it with an illustration. So here is what that might look like. The green shaded region represents 90 hundredths or 9/10. And then we are looking at our divisor of 15 hundredths. And you can see that one is segmented off right here. There's 10, 11, 12, 13, 14, 15. So that is one group of 15 hundredths. And then we're continuing to repeat that. So here's one, here's two, here's three, here's four, here's five, and here's six. So 90 hundredths divided by 15 hundredths is equal to 6. That's one way to look at division. Another way is using the sharing or the partitive concept. And so the next one I will show you using that concept is 0.80 80 hundredths divided by 4. When we're dividing by a whole number, the sharing concept is very helpful. And so this would, just as a reminder, what we're doing is we're taking our initial amount, 80 hundredths, and 4 is the number of groups. So we're not subtracting off 4s. This is the number of groups. And then we're going to examine how many end up in each group. And so it's going to look like this. If we start with 80 hundredths, or again, 8/10, and we segment it off into 4 equal groups, 1, 2, 3, 4, we're then examining how many are in each group. And as you can see, each group is going to have 20 hundredths, right? Each one of those is going to have 20 hundredths in it, right? So there's the idea of the sharing concept. Those are 2 different ways we can think about division conceptually. Let's move on now and examine the paper and pencil algorithm for division. Now we've seen division algorithm already. Let's take that last problem that we just did, 80 hundredths divided by 4. If we use our traditional division sign, it's going to look like this. Our divisor always goes on the outside. And when we are dividing with decimals, we are going to look on the inside, and we're going to bring this decimal point right up, straight up from where it was. And then we ask 4 divides into 8 2 times. 2 times 4 is 8, giving us a remainder of 0. Then we always bring down our next digit. 4 divides into 0, 0 times, subtracting, still leaving us with 0. So again, we can verify through long division that 80 hundredths divided by 4 is 20 hundredths, or 0.20. Now, it's important to note on this example that I gave you, the divisor for was a whole number. We never, in doing long division, divide by a decimal. So when we're doing long division, we never divide by a decimal number. We always make an adjustment. I didn't need to make an adjustment because this one was a nice whole number. But let's look at an example where we would have to make an adjustment. Let's do 1.504 divided by 0.32. If we go to set this up with our long division, we would point 1.504, put our division bracket around it, and then put our 0.32 out here. We'll see that this is a decimal number on the outside. What we do is we change this to a whole number by moving the decimal all the way to the end. And then we count how far we moved it. 2 places. We moved that decimal point 2 places to the right. We then make the corresponding move the same number of places to the number on the inside. We're going to move it 2 places to the right. Then we have 32 dividing into 150.4. And now our decimal point is locked in place, and then we proceed doing long division. If you're curious what that would look like, 32 does not divide into 1 or 15, but it does divide into 150 4 times. Why? Because 32 times 4 is 128. That's as close as we can get to 150. When we subtract, we see that there is a remainder of 22. We then bring down our 4, and we're dividing 32 into 224. And that actually goes in exactly 7 times. We have a remainder of 0. And so our answer is 4.7. And we go back to the original problem. 1.504 divided by 0.32 is equal to 4.7. Now you may be wondering, why do we make that adjustment? And why does it work? Well, we can justify it. And I will show you exactly how we do that. It is essential that you understand why these things work the way they do. So if we take our division problem and we just restate it as its fraction form, we know we can restate a division as fraction. What I'm going to do is I'm going to take that, and I'm going to take both of these numbers in our fraction, and I'm going to multiply them by 100. Why did I pick 100? Maybe you can guess. What happens to our numerator, our denominator, I mean, when we multiply by 100? It changes from 32 hundredths into just 32. And our numerator changes to 150.4. It essentially moves the decimal point 2 spots to the right in both of those numbers. We know that fractions remain equivalent if you're multiplying by the same factor on top and the bottom. And so this fraction is equivalent to this fraction. And this one is what we ended up using here. It allowed us to divide by a whole number because then it kept our decimal. It showed us exactly where our decimal point needed to go. And so that is going to be how we're going to divide with decimals using that long division method. So let's have you try a couple of these. So the first one we'll do is, number 1, we'll do 0.498 divided by 0.6. And the second one we will do is 34.44 divided by 1.4. So go ahead and pause the video and try these on your own. So if you've done these, then you may have started off by setting up your long division problem. And the first thing you would do on number 1 is move those decimals 1 spot to the right, changing it to 4.7. 498 divided by 6. Bring your decimal point straight up. 6 does not go into 4, but it does go into 49 8 times. 8 times 6 is 48. Subtract to get 1. Bring down that next digit of 8, and 6 divides into 18 3 times exactly, and so we end up with 0, a remainder of 0. So our answer is 83 hundredths, or 0.83. For the next one, we have 34.44 divided by 1.4. Again, we're going to move our decimal point one spot to the right in both numbers, giving us 344.4 divided by 14. 14 goes into 34 twice. Make sure you put your 2 exactly over the last digit in the number you were dividing into. 2 times 14 is 28. Subtracted from 34 is 6. Bring down the 4. 4 divides into 64 4 times. 4 times 64, or 4 times 14 is 56. Subtract, leaving us with 8. Bring down that final 4. 14 divides into 84 6 times. I'm going to bring that decimal point straight up. 6 times 14 is 84, so we have a remainder of 0. So 34 and 44 hundredths divided by 1 and 4 tenths is equal to 24.6. Now, just like we did when we were multiplying, we also have to examine dividing by powers of 10. Dividing by powers of 10. Now, you might be able to guess that it's just going to be the exact opposite of when we multiplied by powers of 10. And you'd be right. When we multiplied by powers of 10, 4.5 times 10, we shifted that decimal one spot to the right, 45. So when we divide by powers of 10, we're going to shift that decimal one spot back to the left for every power of 10. 0.45. But it is crucial that we understand why, of course. So let's look at the problem. 37 hundredths divided by 10. And let's look at what the diagram of this would look like. So what we have here, we will examine. Our starting number was 0.37. It's represented here by this green shaded area. If we segment off the first 30 and divide that by 10, we have 30 hundredths, right? This is technically missing its decimal point. We have those first 30 hundredths, and we're dividing them by 10, right? Those first 3 columns, if I even look at them as 3 tenths or 30 hundredths, if we divide those by 10, now we only have 3 hundredths. So those are represented here. So we went from having 3 columns to just 3 squares. We do the same thing with the 7. 1, 2, 3, 4, 5, 6, 7. So we have those 7 hundredths. Well, 7 hundredths are the same thing as 70 thousandths. And if we divide that by 10, we now have only 7 thousandths. So we went from having 7 tenths to just these 7 thousandths right there. And so we can see how our 0.37 or 37 hundredths changes into 37 thousandths when it's divided by 10. Another way to look at this is by examining it with fractions. If we take 0.37 divided by 10, that's the same thing as taking 37 hundredths times 1/10. Because remember, when we divide by a number, it's the same thing as multiplying by its reciprocal. Well, 37 hundredths times 1/10 is 37 thousandths, which is 0.037. So we can see that 0.37 divided by 10 shifts that decimal point one spot to the left. And of course, we had to add that 0 there. And that's going to be the same for however many powers of 10 you are dividing by. For every power of 10, you're going to move it one additional place to the left. So now it's your turn to try a couple of these. We will do 35 hundredths divided by 10 by 100, and 8 tenths divided by 1000. Take a moment and calculate each of those. Again, in each case, we're moving our decimal point to the left, one spot for every power of 10. So divided by 10, we're going to move it one spot back to the left, 0.035. 35 hundredths changes to 35 thousandths. When we divide by 10, that's like 10 to the second power. So we'll move our decimal point 2 spots back to the left. 0.046. 4 and 6 tenths changes to 46 thousandths. 8 tenths divided by 1,000 is going to move our decimal point 3 spots back to the left. So we will have 0.0008, which is 8 ten-thousandths. So that kind of wraps up our division with decimals. We looked at the different models, we looked at the different algorithms. To finish this video, we will explore order of operations, which again, we did this previously in other chapters, but we're going to examine it now with some decimals. And so we have a good application here. If you've ever wondered about where your federal tax comes from, there's a formula associated with it, and it actually involves order of operations. And so here is a scenario. It says, according to the instructions on the tax form, the tax on an income greater than $36,251 and less than $87,850 is $4,991.25 plus 0.25, or 25% really, times the amount over 36,251. So this, first thing I'd recommend is just pausing and rereading this a few times so you can make sense of it before I explain it, then come back. What this is saying is that if you make an income between these two amounts, between 36,251 and 87,850, then this is how your income tax is calculated. It would be $4,991.25 plus 25 hundredths times the amount over 36,251. So let's just say, for example, you have a salary of, or an annual income of $44,600. And you want to know how much income tax you're going to pay. You first have to calculate how much is this number over this number. How would you do that? You would subtract. You would take 44,600 and subtract it, or subtract 36,251. Okay? It's kind of like that that difference concept, right? Comparing them, see how far apart they are. And what we've created is this expression here that involves addition, as we see here, multiplication, which we see here, and also subtraction, which we see here when we've calculated the amount over. So now we have to make sure we evaluate things in the right order. If you recall from before, we always do any grouping symbols first, which means we would start by calculating this amount. Subtract that number, and you will get 8,349. We still have $4,991.25 plus 0.25. And now we're going to multiply that by this. So we still have two operations to go, addition and multiplication. If you remember from before, multiplication and division technically there would be exponents, but we don't have any of those here. But multiplication and division come next. So the next thing we would have to do is multiply 0.25 times 8,349. When we do that multiplication, we get $2,087.25. Finally, at the end, we can do our division. Our addition. Addition and subtraction is going to come at the end. So we add 49.91 and 25 cents to 2,087.25, and we get a total of $7,078.50. So just pay close attention to that order of operation. Again, you're going to do the grouping first in parentheses. It doesn't matter what operations you have in here. You're going to do those first. Then any exponents, we didn't have that in this scenario. You're then going to go to your multiplication and division, which we had here. And then finally, addition and subtraction, which we had here. And remember also, addition and subtraction, if you have more than one to do, you work them from left to right. And the same thing with multiplication and division. So that's going to wrap up this particular video. We have one more left in this chapter where we're going to look at different properties of decimals, as well as how to do some mental calculations and approximations.